Scottish Collaboration for Public Health Research and Policy. It's great to see so many faces, people we know, and some new faces. And we hope you'll stay afterwards and have a glass of wine and nibble with us, in spite of the impending inclement weather that we're now being told will engulf us tonight. My task today is to set the scene for two presentations that you were given the advertisement for. It's a great pleasure to have this work presented here for the first time by people that I think of as young investigators compared to myself, and both of them very talented people, Rob Young and Frank Popham. And in order to give you a sense of why this kind of work matters, particularly because we deliberately invited people from the policy and practice audience, not just from the research audience that we work with in the collaboration, I thought I would put a few slides up, and I've asked their forbearance, Rob and Frank's, to set the scene. It's a very well-known idea in public health, attributed to Jeffrey Rose, that most public health problems have two ways you could tackle them. You could try and shift the whole curve of the risk factor that underlies the health outcome, the disease, cholesterol, BMI, on this graph, high blood pressure. Those are the examples that Jeffrey Rose used. You could try to shift the whole curve by measures that got the whole population, like changing the salt in all foods in a regulatory way. Or you could tackle people who present with extreme values of the risk factor, high blood pressure, very high BMI, and clinically try to diagnose and treat them in a way that's commensurate with their risks. Both of these measures are almost always required for all of the chronic disease risk factors. You can't ethically ignore the people on the far right end of the distribution, but you will find in almost every case, lots and lots of papers since Rose wrote this initially more than 20 years ago, lots of papers have shown that you don't get at the bulk of the disease burden in the population without tackling the much larger group of people in the middle with moderate levels, moderate elevations of the risk factor. So this idea of shifting the curve is a very, very fundamental one in all public health epidemiological thinking. And Rose, in his inimitable way, managed to take it up a notch by equating the idea that you need to shift the whole curve. If you really want to get at chronic disease, the whole risk factor distribution of the population, he used the phrase that you need to seek the causes of incidence, not the causes of cases. And what he meant by that was that the people who have very high levels of risk factor in the extreme tail of the distribution often have genetic components. They often have factors that make them a case, but the factors that drive the position of the whole bell curve, which varies from society to society, tend to be much more cultural and environmental. And he understood that you needed to think about both when you tackle disease causation. You're wondering, what has this got to do with the shape of the curve between socioeconomic status and health outcomes? And I'm getting to that. It turns out, however, that Rose's idea that most of the disease burden is necessarily in chronic disease risk factor distributions, set in the middle of the distribution where most of the people are, that actually depends on the shape of the risk curve. The curve relating the risk of the bad outcome in question to the risk factor. In this case, say LDL cholesterol. So since the first Framingham papers were published now more than 40 years ago, we've known that basically a logistic function, it's just fundamentally exponential, is a pretty good fit to the data, that your risk goes up in a kind of exponential way against your serum cholesterol above a certain level. But if you think about it, the extent to which that risk curve is nonlinear, is curvilinear, concentrating the risk in the people with a very high level of the risk factor, that actually works against Rose's idea. If there's an extremely curvilinear risk curve, then most of the disease burden will actually be down here at the high level of the risk factor. And the idea that you need to shift the whole distribution becomes less arguable. So all of this applies just as well to income or education. It's just that we don't always have the full causal set of criteria that epidemiology wants before it tick boxes causation. So I'm not in time to go into that today, but what I do want to just show you is a couple of studies which have tried to look at what Rob and Frank have looked at in other cultures and settings in the last while. First thing is just so that you're not naive about this. I'm sure you're not. Governments all over the world make decisions every year that massively change distributions of income after taxes and transfers, meaning welfare-type payments. And so you do change. People change the net, so-called net income distribution by policy maneuvers every day in the Western world. So the idea that it can't be changed is not true. It is changed. It's just that we often don't realize what's happening in the same way that the people at the Exchequer's office do, Chancellor of the Exchequer. So you can say, therefore, that in tax policy terms or income maintenance policy terms, the idea of lifting all boats, rising tide lifts all ships, a good business cycle lifts up the poor, lifts everybody up, is analogous to Rose's idea of shifting the whole curve, but for income instead of cholesterol or BMI or all the other risk factors for chronic disease. Whereas the idea that you want to fight poverty, if you're just in a poverty reduction policy mode, then you're just tackling the tail. You're using a high-risk approach. So the analogy is quite precise. So we have some studies, very well done studies from around the world, but each of them with strengths and weaknesses that suggest, in some cases, rather linear patterns, and in some cases, sharply curvilinear patterns, if we just take the same SES marker, income, and the same health outcome, mortality, from all causes in adulthood. And you might say, well, those are not very satisfactory because they're not A, a full measure of social class in the case of income, B, a full measure of health, but they're very well measured. So let's just look at those two studies. In the United States, a record linkage between the National Health Interview Study survey involving hundreds of thousands of households and mortality database, an anonymous record linkage, anonymized, produced these two curves. This is the actual income distribution in the United States. It's gotten a farther right tail in the era of Reagan and Bush as people are given tax breaks in this category. And I noticed Obama yesterday managed to give another set of tax breaks to folks out here. So that skewing is the people who largely made their money through that sort of arrangement. But this is what I want to draw your attention to, is that carefully splined, meaning, as you'll hear from Rob, a form of a regression that doesn't assume a functional fit, although these guys did play with some functional fits. And I think, as I recall, logarithmic was the one that they thought fit best. But in this particular graph, what you see is the fit. Those are 90% confidence intervals, so they're very, very tight. For the risk of all-cause mortality in a large cohort of adults over something like 6 or 8 years of follow-up, a little bit. Perhaps let's show you in a minute. And what you see is that there's such a concentration of excess deaths amongst the very poor that you probably should be fighting poverty first if you think causation is really going on here. Unfortunately, that's not what the Canadian data show. From an even larger record linkage of all the people who ever contributed to the government-sponsored pension plan over a very long period of time, my colleague Michael Wilson and his colleagues in Statistics Canada showed an almost linear pattern. Now, this is, however, in a little older group. These are people in their first 5 years after retirement, and their risk of death was absolutely linear related to their earnings over the previous 20 years, which is very nice because it takes out the possibility of reverse causation, meaning you started measuring their income a long time before illness that precedes death could have caused their income to go down. So which is the truth? Well, we don't have time to go into all the reasons these studies are probably, in either case, not the full truth. I've put a bunch of reasons down here. The only point I would make, rather than get into epidemiological minutiae, if I want more time for our two speakers, is that if you stopped and truncated the first curve and left out the poor, the really poor, and people who don't work, you'd have a pretty linear picture. And that's what the Canadian curve had, because the Canadian curve was only people who contributed to the national pension scheme for a long time. So there might not be that much discrepancy between the curves. What about Scotland? Well, we actually have an old graph. I dug this up, and somebody here may actually be able to tell me the answer to my question. It shows that when you use the old, I think it's Carstairs deprivation index, you get across 7 levels. Scots respondents on surveys wouldn't tell you their income. So you had to ask them about other things in their lives, car ownership, TV ownership, indoor, outdoor loo. Those are things that were still relevant in that period, the 1980s. They followed up a very large cadre of Scots, and they found this incredibly linear relationship between all-cause mortality and their deprivation category. Now, the reason I should say I'm reluctant to go further with this and Peter, you probably know the answer to this, is that I don't actually know if the Carstairs index is set up to be even quantiles. Are these setiles? Are they equal sevenths?
No, they're not.
They're not. So we can't conclude that it's linear because we actually don't know. This thing's a categorical variable, is that right?
Not from the depth cats. You could from the scores.
You could from the scores. So it wasn't presented in this slide in a way that would tell you whether it's linear or not. So it seemed that's very old data. It seemed that we needed to look at all this again. Unfortunately, there's been a very impressive series of reports by Health Analytical Services, which I personally view as the most sophisticated in the world in the last 3 years. And they use ecological, but very finely graded, very finely mapped assignments of people's income and unemployment rate, the so-called Scottish data zone, 6,505 of them for 5 million Scots. It's pretty finely mapped. And in that, they are analyzing a bunch of health outcomes, 11, which I'll show you just a few examples of, rank ordered into deciles. So they have the first decile of poorest Scots by postcode, mean Scottish index of multiple deprivation, right up to the top decile, richest Scots by postcode of residence. And they have shown in all these cases, I'll show you a couple of the graphs as examples only, how the dose response varies across the socioeconomic variable. How is it linear or curvilinear? And that's the part that Rob wanted to tackle. And second, that they did it only in this broadly ecologically assigned way. They didn't use individual level data for social economic status. And that's the part that Frank will contribute today. They did a bunch of other things. They looked at time trends in the gap between the bottom, the absolute difference between the top and bottom rates of bad events, and the health events for the Scottish population. They did it for each year over about a decade. This year's October report covers a full decade. And the bottom line is, and this is the hard bit for policy people, is that not one of the 11 health outcomes analyzed show major reductions in the absolute rich-poor gap in the decade. And I've written with Sally, my colleague, who sends her regrets today, a paper about why that might be true, which we don't have time to go into today, but because we're trying to get on to new methods. But there are some reasons why probably those indicators are no longer sensitive to policy initiatives that can be executed within the life of 1 or 2 governments, 5 or 10 years. But two, both related to alcohol consumption, 2 outcomes, hospitalization and death, show widening gaps. I'll show you one of them. And one of them shows some population level improvement, coronary disease, is coming down the rich, coming down the poor. The gap is very, very much unchanged. So this is a typical graph. Tends to be healthy life expectancy from the October 2010 report. So it's, in the richest Scots, these are males. The female differences are just slightly smaller. We have a healthy life, being in reasonable health, being alive in reasonable health, of about 75, 76, 77 years. Flat as a pancake in the last decade, and for the poorest Scots, nearly a 20-year difference. One of the, as you'll hear, one of the largest differences in Europe. What about the question that Rob's going to tell us about, a new tool to analyze, which is what's the shape of the relationship between socioeconomic status, in this case SIMD, the Scottish Index of Multiple Deprivation, postcode assigned. What's the shape of that relationship compared to various health outcomes? And the answer is, in this series of 3 reports, for 9 of the 11, the relationship of the outcomes between this marker of local socioeconomic deprivation, if you will, and the risk of the outcome in question is amazingly linear, just like physics. And here they are. I'll just show you some. Healthy life expectancy across the 10 deciles. Mean, I always get this wrong, but it's a score of health and well-being derived from work at the University of Edinburgh and Warwick, I believe, right? So it's a score of a psychological score in a survey. Got nothing to do with death or hospitalization. Amazingly linear. Rates of low birth weight babies, prevalence at birth of babies under 2,500 grams. Astonishingly linear. Hospital admissions for heart attack amongst those under 75. Unbelievably linear. Cancer incidence on the registry. Linear. Last one is the one that isn't. This is alcohol mortality. It's also the one that shows the worst time trends, with steadily departing and elevating every year rates in the poorest, and flat as a pancake rates in the richest. So the inequality's gotten bigger and bigger. But what's unusual about the dose-response curve is there's a sharp excess in the poor. So without getting into a lot of technical details, one of the tools used in this report and recommended for use by guidelines writers around the world for analyzing health inequalities is a little piece of algebra where you subtract the rate in the top, hypothetically top person from the hypothetically bottom person across the SES range of the population, the rate of the outcome, and you divide it by the mean of the whole population. It's called the relative index of inequality. And the problem is that you shouldn't use that if it's not a linear relationship. And so the question arises, what bias is introduced by using it when it's not linear, as in this case? And so, without going on about what that would mean, it's a critical tool that we asked Rob to have a look at because he is unusually skilled statistically. Although, as you saw from his little bio, his background is very much in genomic statistics, but he turned out to be a very quick study. And so here's the two questions. This is for Rob. Is there a robust but easy way to check for the linearity assumption that should be met by SES and health risk data before utilizing the RII as a summary measure? And could we quantify any bias in quantifying in using this index when the assumption isn't met, if you like? And the second question, and this is taken a great deal of work, and so to Frank's credit, the team at the Scottish Longitudinal Study that he's worked with have spent many months doing this. How different would the Scottish health inequalities look if the socioeconomic status was assigned to individuals? We had their census data on their education or income, as opposed to the postcode assigned mean value of their neighborhood. And the standard epidemiological answer to that is the inequality should be more steep when we have individual level data, because ecologically assigned data misclassifies some of the subjects. But is that true in a society which has sharply demarcated housing estates and where postcode-based data zones are almost always smaller than that? So it might be there isn't much misclassification, and maybe it doesn't matter. Maybe we don't need to. So with no further ado, let me go ahead and get this up for you.
I'm going to talk today about what is the shape of the relationship between socioeconomic status and health status, as John introduced. My talk will have 4 sections. I'll give a quick introduction to exactly the question I was working on. I'll try and describe the methodology that we've developed in a bit more detail so you can understand quite how we've got the results we have. I'll show you the results of 2 small analyses we've done, one using the ecological data zone level data and one using individual level data from the Scottish Longitudinal Study. And I'll quickly conclude at the end. So, as John said, inequalities in health are observed across most societies, where those at the lower end of the social hierarchy generally suffer more from those at the top. And health interventions to really alleviate this, such as the Scottish Government's Equally Well programme, depend on a robust and straightforward way to monitor these. So there's lots of people who are monitoring how well health interventions work may not be deeply qualified statisticians. There needs to be a simple, easy way for them to understand the data that they're monitoring and be able to present it in a way that makes sense so they can work out whether these interventions are worth doing, whether they're achieving the goals they were set out to do. And a variety of different measures exist in the literature, varying in complexity, from very, very simple measures to very, very complicated ones which I can understand at all. But I think kind of the idea is that we have something simple and straightforward. So it's another graph of the type John was showing about how the Scottish Government looks at inequalities across society. So these are data zone deciles again across the bottom, from least deprived at the left-hand side to most deprived on the right, against alcohol-related hospital admissions. So here they've scored deprivation using an income employment decile. So this is a part of the Scottish Index of Multiple Deprivation, but it only uses the income and the employment domains of these. And then the reports that John was describing report what's called a relative index of inequality, which is simply the slope of this regression line. So it's how steep is it? How much does health get more unequal as you go through the deciles? So it's simply the relative difference between the top and the bottom of the slope. And the question I've been looking at is this assumption of linearity valid? So is this line an okay line for you to fit this sort of data? So some people have looked at it before. This is what I think is one of the best studies that have done this beforehand. This is based on an American study, so they've looked at years of education on the x-axis, so that is their socioeconomic status, and then they've got relative risk of mortality up the side as well. So they fitted a straight line, as you can see in this grey line here. So this would be kind of your conventional relative index of inequality. They've also fitted two other models. One, where they have horizontal lines, which are in these thicker lines here, which are allowed to change at two given points here and here. And these thinner lines here, well, they allow there to be a slope across the groups, but these slopes themselves are allowed to jump at these 2 points. These 2 points here are previously well-defined educational thresholds. So 10 years is the end of high school, and 15 years is the end of college. So they think that the thresholds are likely to come there because obtaining these statuses gives you the real protective effect. So they use simple regression models and what's called a likelihood ratio test to test between which of these gives a better fit. And they find that there is support for these step changes at these individual points. However, the problem with this is that they've only tested these 2 individual points for the lines to change at, which if you look back at the Scottish Government report, it's hard to think exactly where we would call 1 or 2 turning points to be in the data. They also have no quantification of the overall cost of the inequality. So they report these relative risks, so the risk of death compared to the top group for the different years as you go through education, but there's no attempt to try and quantify that across all of society. And so it's difficult to see how they would manage to monitor this over a number of years. So this is the methodology that we have developed. This is again, it's going back to the Scottish Government graph here. And what we are doing is we're doing a regression model, so we're fitting lines to it as well, just like they were. But we now allow there to be possible turning points known as knots to be placed at the end of each category. So that's what all of the arrows represent. So we allow there to be a non-linearity at every one of those points at the first stage. You notice there's not one in between the very first 2 groups. That's because when we come to monitoring it, what we're doing is we're saying, is there a change in the slope between each of these points? So of course here, you've got to set up the slope between the first 2 points, and then it's allowed to change at each of the subsequent ones. And as I'll show in a little while, our methodology is also able to account for population size. So if the groups are not equally sized, you can still place the knots in between each of the categories. So first of all, it starts by fitting a regression model, as I said, with a different slope between each of the knots, where the significance of these can be estimated. This is just using a simple regression modeling. And you can use this in linear regression, Popham modeling, or Cox modeling you try it in. And then what happens is you test the significance of each of these knots, and non-significant knots, so that's knots, we've chosen a p-value cutoff of 0.05. Non-significant knots are removed, and the model is refitted. And this is repeated as many times as there are original knots. This is because, as I showed before, if you remove one of the knots, say this knot, and refit the line, the slope going from here to here becomes different how it was considering them all together. And so the significance of a knot, which was significance in the first round, can then lose its significance in the next round. So it's repeated as many times as there are initial knots, therefore allowing you to remove one knot every single time in principle. Although we found that it frequently stabilizes after 1 or 2 rounds, and you just keep iterating over the same knots. And finally, we use a likelihood ratio test to confirm that any of the decreased parsimony is justified. So by that I mean we compare the model, the traditional model using a continuous linear fit, like I've shown before, versus any of our models with a knot in it to see whether you see a significant improvement with the knot. Although with all the times we've done it so far, I've yet to see a failed likelihood ratio test with a significant knot, so it's probably just a double check of this. So, and then we have 2 different summary measures for which to quantify the effects of this model. The first is using what's called the population attributable risk. And this is one which is suitable for all 3 model types. By 3 models, what I mean is that we have, first of all, our spline model with the 1 or 2 knots in it, the continuous linear model, so the traditional straight line, as we've shown before, and a categorical model. So this is a regression model where you fit every one of the categories as a separate variable. So this is considered kind of our gold standard idea of what we see in the population. This is the equation for it. So the population attributable risk is given by this, where PG is defined as the prevalence of the health outcome in that group. So it would be, for example, the proportion of deaths which were observed in that socioeconomic group. And the RR is either the relative risk or the relative incident rate in that group compared to the group with the highest SES category. It's relative risk if you're putting a Popham model or a Cox model, incident rates if you're putting a linear regression. And the groups that you can use this calculation for are those defined by the initial categories, not by the significant knots you've called. So, for example, in a Scottish Government analysis, you would calculate it for each of the 10 deciles that were originally present. We're also able to estimate the relative index of inequality. And so in a continuous model, it's just done as normal as the relative difference between the hypothetical individuals at the top and at the bottom of the population. So for a continuous model, this is simply given by the regression slope when you pick the model. For a spline model, you obviously have more than one slope across the model. And what we do is you weight the slopes by the distance travelled. So for example, if you had a significant knot at 0.5 in the population, you'd have 0.5 times the first slope and 0.5 times the second slope, which would give you your relative index of inequality, which compares to the difference between the hypothetical individuals in a spline model. So here's two examples of the data that we've analysed. This first one is at data zone level, so it is alcohol misuse versus deprivation. So across the x-axis in this graph, I've plotted the income employment index as before for this government report. And up on the y-axis, we have the hospital admission rates for alcohol misuse. These are slightly different to the ones I presented before. We didn't have access to the same data set they had. So this has just come from Scottish Neighbourhood Statistics. So the histogram shows the categorical fit. You'll notice I've scored each of the groups by the midpoint of their position on the population distribution. So they're at 0.05, 0.15, 0.25, which is kind of the classical way to calculate the relative index of inequality. So that's the categorical fit. The continuous fit is shown by the dashed line. So it's exactly the sort of thing you would do kind of traditionally. And then the solid line is the spline fit. So the spline fit here with our significant knot here, called here at 0.9. So that's in between the second least and the most deprived population deciles. So the spline fit, as I said before, always has statistical support, it passes the likelihood ratio test, and the knot is highly significant. When we calculate the population attributable risk, we see that it's much closer. So it's at 0.82, which is much closer to the categorical's 0.94 than the continuous at 0.73. So your continuous traditional fit underestimates the cost of the inequality across society. However, when we then calculate the relative index of inequality, we see that the spline one is much greater than that for the continuous. So, as we said before, the relative index of inequality is the difference between the hypothetical individual at the bottom and the top of the distribution. So I plotted them here in these dotted lines, as you can see. So for the continuous model, you assume the model just continues expanding out beyond your data space. So it just goes from here down to the bottom, which is why it gives us value of about 3. Whereas the spline model, because there is a knot here, the slope increases really quite steeply here. And as we have no data to carry on, we've then extrapolated all the way out to the top. So this straight line continues here, and obviously it goes a lot higher than what you would expect. And so we were worried that possibly our modelling approach is kind of failing here, and that we're shooting ourselves way off into the distance. So to try and have a look at that and to understand exactly what's going on in this instance, we split the categorical fit into many more deciles. So we've now, instead of having them into 10 deciles, we're now into 50 categories. So you can see that's why there's many more bars along here. Therefore, the extra data space we have at the very end is much less. So I've just pointed that here, and all I've done is plotted on the top the same fits that I showed you before based on the 10 categories. And you can see that actually the spline fit is surprisingly good at the very top. So it does go shooting off at the very bottom, and there's a massive increase in hospital admissions in these very bottom deciles. So the large relative index of inequality that we report for this data set does seem to be truly representative and capturing what's going on in the population. Secondly, we've had a look at some individual level data. So this has come from the Scottish longitudinal study. So here we've been looking at, like the American study I showed at the start, we're now looking at education status and comparing this to the risk of death as well. So here we have education status. It's categorized as the highest qualification obtained by an individual, and there's 5 possible categories along the bottom. And then we've calculated the relative risk of of death across on the y-axis. And this was fitted using a Cox model where age class and sex were fitted as other covariates. So just as before, we have the categorical fit in the bars, the continuous kind of traditional fit in the dotted lines, and the spline fit in the solid lines. So again, the spline fit has statistical support. It passes the likelihood ratio test. And there's a significant knot after lower secondary education. So that knot is called here. The difference here is because it's not these are categorized as individual groups, so there's no information on what the difference is between each of these, and so the knot is simply called added position here. And when you calculate the relative index of inequality, these values converge on 2, which is what you can see here. All of them are calculating a relative risk of the individual at the top relative to the bottom as 2, which seems not surprising for the spline fit. So it calls a knot between the second bottom and the bottom category. And as there is no constraint on where the line can change to, obviously the best thing for it to do is to move up to fit the data. But I was very surprised that the continuous fit is also seeming to calculate quite a good relative index of inequality, given that it's not very good in the middle of the distribution. And one thing we thought then perhaps was that it was because we weren't taking into account the population size of the groups. In this analysis, each group has equal weighting, but it doesn't mean that they have equal numbers of individuals. So we're not studying these across society, it's more across education classes. So we recoded them so that now each class is the midpoint of its distribution in the population. So this is analogous to how I was showing you before for the deciles. And you see that there's a vast difference in the size of the different groupings. This bottom group in particular is really quite big. So this is kind of analogous to how I showed you for the decile study. And now we call the knot at the edge of the categories. So the knot between lower second and no qualifications is now called at this point here. However, the knot is now only marginally significant, so it has a p-value of 0.095. So it doesn't really pass our test, but that's where it's got anyway. And we've looked at a few other different SES measures as well, and found that when you account for the population distribution across like this, you often lose the significance of the nonlinearity. The population attributable risk values that we calculate are all around 0.39, and the relative index of inequality estimates for the continuous and the spline models are very similar in this case. I think this is probably due to the low significance of the knot, so you can see that at the top they're pretty much at the same distance. But it can be done. That's the point of this. So, the final point I wanted to make is that these relative index of inequality estimates are based on hypothetical individuals at the bottom and the top of the population distribution. And although I showed that for the alcohol example, it actually was a very good fit beyond these, it may not be appropriate to extrapolate this in examples like this, because the spline models are what we call data-led. So we don't know where the knots are, we call them based on the data itself. So if you're going to if you have all of this distance here, I've assumed it continues linearly at the same slopes it came from here. But I didn't make that assumption across the rest of the data at all, so it's not clear if that's a valid point or not. Especially an example like this, where 30% of the population is beyond the midpoint of the two most extreme groups. So I've done it here, but it's still something which probably needs a little bit of more work if we're going to continue to use the spline model in this context. So to summarize quickly, individuals in the bottom 10% most deprived data zones seem to have an increased rate of alcohol misuse, which is disproportionate to their position in society, so it's not a linear one, it's getting increasingly high. Something I didn't show you about, but there is no nonlinearity in the relationship between coronary heart disease and this same measure of deprivation. This was just to show that actually this model is not just capturing noise in a large data set. You can study it and you can test for linearity and find that actually there is a linear relationship. So that was that one. And at the very end, the increased risk of mortality for people with no qualifications is only significant if you ignore the size of the population groups. If you take that into account, it often actually becomes surprisingly linear. So this new spline-based approach is simple, yet really quite powerful. It can simultaneously detect the number, location, and magnitude of these turning points known as knots in any relationship to the type described here. And it can do this using simple regression modeling. The use of two standard reporting statistics that I've reported here, the population attributable risk and relative index of inequality, makes it very straightforward for these results to be interpreted and to be understood. And It actually is really quite simple. It's just a recoding of the variables to fit these supply models. So it can be implemented in any standard statistical packages, although we've been using Stata and have written an automatic ADDIE file which will implement all of this for you and actually goes from the data set to those graphs as I presented them. I'd like to thank John and Sally and Scottish Collaboration for kind of proposing this project, Alistair Leyland for suggesting that we quantify these things in the 50 categories, because that really helped a lot, and the people at the Longitudinal Study Centre who helped us with the data and to get those graphs prepared, and the MRC who funded this one.
You want to get your slides up, and I'll just see if there's any questions of clarification. We'll also have some time for questions and discussion afterwards. But while we're putting the next set of slides up, are there any questions of clarification or lack of clarity? Alice?
In some societies and for some measures, income and employment are independently related to adverse outcome. Have you thought about how you might refine your model in that way?
It can be done. They were simply decile based on that. What we were trying to do was to replicate the government report as closely as possible. So we've actually combined them the same way they did. But it's just kind of the method just takes a simple continuous measure. So whatever you wanted to use could be applied to it quite simply.
So you could easily take the income and the employment domain and just use them separately to redo it. I mean, it was interesting because I think we used the overall multiple deprivation index first time round before we used the income employment, and it really didn't make much difference to the alcohol example. I mean, we still called the not whatever we sort of used at the bottom.
So, for example, you could take the individual level SES data. Well, you don't have it for income, but let's say you had it, and you could do a multivariate Cox model. You could just work it out for both main effects for education and for income. And we'll hear now why they don't have it, or we'll hear what they do when they don't have income. I think it's one of the things about longitudinal study, right?
Yeah, I mean, to be fair, that we did actually do some work using income because essentially you can use. With the great data in the Scottish Longitudinal Study, at the individual level, we can map onto a very small area geography the similar income domain, basically, from the Scottish Index Multiple Deprivation. And we did a bit of that, and essentially we found that we weren't calling knots, really.
No, because we were sort of taking account of the population distribution.
Yeah, and once we did that, it really seemed to get rid of knots.
No, so linearity was good enough.
Yeah.
Was there another question or comment there? Yes, go ahead.
Yeah, I was going to ask you, did you apply the same model to the mortality, the alcohol-related mortality?
Unfortunately, we couldn't get the exact data. The trouble seemed to be is for our method. Sorry, I'm answering the question. Okay.
Well, all right.
We basically the data that we could get hold of for that, if I'm right, would be basically just aggregated up at the 10 deciles level, and essentially for our knot method, for the spline method to work, you need variation, and basically you need the rate at the data zone level, and because of confidentiality reasons, we couldn't get it in time for.
But you could get mortality data. I'm Rosalia. You actually contacted me for the data.
Yeah.
At Scottish Government, and we couldn't give you the hospital admission one because we don't hold the data. Right. But I think you could get mortality data from DRO, and it would be quite interesting to apply the same thing.
For in the SLS, the reason we didn't look at the alcohol as a separate outcome is because it would be an issue of power, because it's a 5% sample, and our fear was that basically we were maximising here, and to some extent the amount of deaths aren't going to be enough, really, I think, for calling not significant knots. That was our concern. We haven't tested that, so that might not be true, but
we'll pursue that. That's a great point. So thank you.
Yeah,
I should be able to do that.
Interested in giving you some
Absolutely.
I could find out. I mean, you've emailed me in the past.
Yeah.
So I could find out and see whether we could give you the
Yeah.
mortality.
I mean, the reverse is that we are quite happy to hand over the a do file and see if people can make it work on data sets as well. So.
Excellent. Go ahead.
It's just a quick point about your alcohol stuff. Thanks for a very nice presentation. You had confidence intervals, which were presumably kind of binomial things on your separate things. I wondered if you didn't. I mean, it was clear that there was curvilinearity going on in the lower part of that graph, and I wondered if you tried fitting, these kind of cubic splines where you can put in 2 or 3 points and get a really nice fit. I'm sure you could have done a really good better.
We didn't try. We preferred to stick with kind of the simple linear model that we got. So
it was clearly a quite bad fit there.
It was an improvement, we thought, on the continuous model. So it meant that we can easily calculate the relative index of inequality and the population attributable risk, which we felt was an advantage, whereas these kind of more complex models, it was hard to know quite what was going on with them.
Because there has been some previous work that's related, and I mean, because this is a paper that was done and it's implemented. I think there was a 2006 paper on fitting quite complicated sort of in R. And the thing that we were noticing is a really effective method you can get, but we looked at how many times it had been cited and used. And
too complicated.
And it came out that people, and it wasn't many times.
And the stuff that Bendix has done, that would have been an absolute dead easy fit for that. But I see your point.
I mean, there was a desire that it would get used and still be relatively simple, whereas our thought was that the really complex stuff it wasn't getting used, basically. So.
Yeah, good point.
Yeah. Okay, well, we'll go on and have the rest of it. Thank you, Rob. That was great. Frank, go ahead.
Okay. Thanks, John. Basically, I'm not going to sort of talk so much around the sort of non-linearity. Basically, I'm in these methods assuming a lot of linearity, and I'm not really going to repeat a lot of the results that Rob showed, which sort of come out of this initial project as well. The main thing I'm actually going to do is go and focus on something a bit novel, I feel, and think actually a sort of a good way that we can sort of easily get a handle perhaps on the extent of inequalities in Scotland compared to elsewhere, not just in Europe in fact, but elsewhere in the world, using readily available data, and more readily available than some of the data sets that are commonly used to comparative work, and also have a longer history to them as well, so we can look back in time. Not a replacement, but certainly complementary. Basically, just to give you a bit of background to where this is coming from and why originally John approached us about doing this work, and we were really keen to do it because it's very interesting and actually starts to place Scotland in a European context where it wasn't there beforehand. Essentially, there's been quite a history coming out of Holland, led by Johan Mackenbach, of doing European health inequality comparisons. So basically looking at the extent to which health inequalities vary across Europe, and essentially trying to see if that depends on the policy sort of context of the different countries. There was work done in the 1980s, using data from the 1980s, and work done using data from the 1990s. The data from the 1980s got published in the Lancet in the late 90s in a very highly cited paper, and the main finding coming out of that sort of work, which was quite controversial at the time, was that effectively it was thought that Scandinavian countries should have the lowest health inequalities, but it was found that basically the evidence was that they didn't necessarily have that. And there was a lot of debate around some of these issues. And the data using the 1990s, the most recent work was published in the New England Journal of Medicine, so the highest rate impact factor medical journal, so it's a highly cited paper now. And again, it found that necessarily the Scandinavian model wasn't producing the lowest inequalities necessarily, and that report emphasised greatly the importance of health behaviours for health inequalities. Is their conclusion. In all these sorts of studies, Scotland was excluded, and mostly the studies, especially the sort of later 1990s work, were mostly based on studies that are what I would describe as census linkage studies, essentially that they link vital events like death, which is the main outcome in this work, to people's census returns. And until very recently, and thanks to Paul Ball and the GRO, we've now established the Scottish Longitudinal Study. But prior to very recently, Scotland didn't have such a study. And so it was excluded from this work. And essentially in these reports you got the annoying thing that the UK was covered by England and Wales data. So essentially what we tried to do here was replicate some of this analysis for Scotland. Okay. At the same time, I was a bit sort of frustrated by some of this work in the terms of that there's quite a few issues around these European comparisons, particularly about how comparable some of the socioeconomic measures are, how you go about looking at it. And these are difficulties with any comparative study. So I was sort of wanting to not invent new methods, perhaps as my point suggests, but maybe apply some existing methods to this to think about another way of looking at inequalities. So I'm going to present some of that as well. By replicating for Scotland, I've got to emphasise that this is work that's independent from the European work, that I'm going to put it in context. And so there really is a need for Scotland to be included in future European studies. And there is an existing one going on now, and it still is our hope that Scotland will be included, though there are certain things about data sharing that may get in the way of that. But our hope is that Scotland will be included in the next round, so Scotland will be actually part of the next Mackenbach round. And in that, we'll be sure about the conclusions, because in any replication study, you're slightly withdrawn from the original data. Okay, so the data and oh no, I've called us the virus or something. Okay, let's hope that doesn't appear. My slides don't all go wonky. Okay, so the data and methods. Basically, we're using the Scottish Longitudinal Study, and also they looked at some other outcomes in the Mackenbach work, including smoking and rates of obesity, and also things about self-rated health. And to do that, they used health surveys from a number of European countries. And the nearest that we could get was the Scottish Health Survey for 2003. So the Scottish Longitudinal Study is a 5.3% sample of the 91 and 2001 census, and the 91 and 2001 census data is also linked together, so fantastic resource. And all that's also linked to vital events, and the most relevant being for us mortality in this study. Rob's already described the relative index of inequality, and also we use the slope index, which is essentially just the absolute version of the relative index of inequality. Just to say that the relative index of inequality is often coming out of some work by Mackenbach as well, is often calculated, is standardised in two different ways, basically. You get the theoretical people at the highest and lowest of the population distribution, and you either take the ratio of those groups, and this is what we're doing, or you divide it by the mean level of health in the society, which is another approach. And basically, I put the word again because basically I was trying to replicate the results as possible from the New England Journal of Medicine work and also other things for Scotland. In other work, to extend this, I've taken a sort of a life table approach, building on work from demographers, and I'm going to use the Human Mortality Database that, if you don't know about it, is a collection of life tables for a large range of countries, collected by demographers worldwide, and they do a lot of work to make them consistent over time, and we've got very good data for a lot of countries from 1950 onwards, and for a lot of countries going back, Sweden going back into the 18th century, in fact. And basically, demographers have always not just looked at life expectancy, say, if you take that as being the average age of death, if you like. And, they've also looked at variance in life expectancy, and they use all sorts of different measures. My argument is that actually variance in life expectancy is a measure of inequality, essentially. And increasingly that's recognised somewhat and being used in that work. And in fact, there's ongoing work comparing both approaches as well. So basically, because we've got a longer run and we could compare Scotland with lots of other countries, I wanted to use this as well. And I'll explain a bit about lost life expectancy in a moment. Okay, so let's go on to some results. The first difficulty I've got to say is that Scotland in 1991, we basically used education as our measure of SES, because that's what Mackenbach did as his main measure, though he also used social class. And we get similar results for Scotland for social class as well. In 1991 in Scotland we only had 3 categories of education. And basically it really was only splitting up higher education from the rest. So you've got to be a bit wary about the 91 result. But basically the European results, and all these are all the countries, and this is the relative index of inequality, which is the ratio between the theoretically highest and lowest placed person in the society. And effectively, the relative index of inequality takes account of the different population size in education groups between the different countries as well. So it attempts to take into account. It doesn't take into account the meaning of the different education groups, which is always an issue. But anyway, this is 91, and we're comparing it to 91, and the relative index of inequality for 91 in Scotland was 3.19, far too precise, but I'll draw it more imprecisely on a graph there, and there we go. And basically that's not a good story for Scotland, comparatively. I think that's actually a bit high for Scotland. I think in the other countries they were using slightly more defined education. I think it would be a bit lower, but I still don't think it would be that much better. Okay, so effectively it's only sort of Scandinavian, not Scandinavian, Eastern European and ex-Soviet countries I think are doing worse. In 2001, we must remember this is 90s data, and I should say 91 is a follow-up period till 99 is for mortality that they used, and 2001 went to 2007, which was the latest data that I had at the time of this study from the SLS. So this is risk of death, and this is for men, and not a good story for Scotland comparatively. Okay, so how about for women? I apologise for that. In 91 it was about 2.2, and 2001 a bit higher in fact. And again, not a good story outcome for Scotland relatively. So high inequalities relatively that we were finding. So, from this results, we were also able to look at sort of in absolute terms to say what was contributing to the inequality by looking at the slope index of inequality and essentially looking at sort of the types of disease that were contributing to the overall level of inequality within Scotland and sort of see how that sort of compared with the rest of Europe. And essentially it's quite difficult to define what smoking-related causes are. You can go very specific causes that, such as lung cancer, that are clearly the majority of cases are smoking-related. But smoking plays a big part in a load of other disease. And as Mackenbach found for other European, Northern European countries, that smoking was a very important related causes of death. Causes of death related to smoking were very important for the overall levels of inequality in Scotland. The analysis of the Scottish Health Survey data, we also found that the highest relative index of inequality compared to slightly smaller number of European countries were found in Scotland. It had the highest level of inequality in Europe in terms of smoking behaviour. Again, if we looked at self-rated health, and how they did this was quite interesting, in which they gave a weighting to categories of self-rated health. So a question where people asked them about their health, in which they scored it very good through to very bad. Essentially, they looked at how many diseases people had in the Mackenbach work for those particular responses. And effectively, they found that you could give them a score, and then they used this new measure to try and draw out sort of differences, and they found that it gave much different results to when you dichotomised between people with good and bad health. But when we used this method, we found that in Scotland, inequalities in self-rated health were comparatively, again, very high in Scotland compared to the rest of Europe. And there's more details about this in a report that will be published on the web through the Scottish Collaborations website. Finally, obesity inequalities were not comparatively high, and we can discuss some of the reasons for that, and John has some good theories about that, but they weren't as outstandingly high in Scotland compared to the rest of Europe. And one reason is because actually the overall prevalence of obesity in Scotland is quite high. So the differences weren't as great as may have been expected, perhaps. Okay, so now I'm going to change tack, and I'm sorry for moving through quite a lot of these results quickly, but this is sort of newer data, and I've been told not to move all the way over to this shot, but I'm going to block the graph for a moment and just explain what life expectancy loss per death is. Essentially, this is the idea of, and basically you get the same results from any measure of variance in the age of death. Demographers have shown that essentially if you can calculate a Gini coefficient as a measure of variance, or some form of standard deviation from life tables to get variance in death in populations. We're using life expectancy loss because you get it, it's in terms of its presentation, it's in terms of years, and is related to life expectancy in those terms. So that's years lost. And basically it means, on average, when somebody dies, how much life expectancy they lose because of them dying. And the simplest way to explain it is to imagine that if I was to die, say, at age 50, and life expectancy in the society for somebody age 50 was 30, and somebody age 51 was 28. In fact, I take the average of that, so I'm losing 29 years of potential life, okay, by dying at age 50 in a society. And basically, you just weight that by the number of deaths that are happening in every age and sum it all up. And it gives a summary measure of the overall level of inequality in death. So if everybody died at the same age in a society, this measure would be 0, okay? And that would effectively mean that everybody was living to 80 odd and dying at the same time. Very odd situation, which would never occur. But the measure is a very powerful way of summarising. And the good thing about this is that you need no measure of socioeconomic status to do it, which is an advantage. Okay? This is the worst graph in a presentational form because the dots are too small. I apologise. I spent so long trying to summarise loads of data on this graph. But essentially, this is the average life expectancy lost for a variety of different countries per death, the average amount. And effectively, the black dot for men and women, and this is the average over each of these decades from the 1950s onwards. The black dot is Scotland. And the higher up the scale it is the more inequality you've got. Okay, so Scotland is going in a worse and worse position over time. Yeah, and effectively, this dot here which hasn't always been here, but if somebody wants to hazard the guess, if I say that I've included not just European but North American countries in here, that's the United States. Okay, so we're only second worst to the USA in terms of inequality. I haven't included all countries here because there are some countries that are worse, but they're not really countries you want to compare yourself to in Scotland, and we certainly shouldn't be doing that, but I will do that in a moment. So effectively over time, and I can illustrate this comparing us to 3 countries. This is for men only, and I apologise for limiting my slides to men only. The patterns are more dramatic for men, but you get similar patterns for women over time as well, but not so dramatic. But effectively, this is the pattern for men. So this is lost life expectancy per death in Scotland from the 1950s, and we compare it to Sweden, and we compare it to England and Wales. We can see downward trends, certainly for Sweden. England and Wales, slight slowing, but still a downward trend. In the mid-80s in Scotland, it's flattened out. And that's quite rare, in fact. In fact, that's very rare. This shouldn't really be happening. And you can decompose this and find out which age groups are driving this. Okay, and it's a complex area, but essentially some work from Alistair Leyland and others that we know that we've had problems with death rates amongst age groups of sort of 30s, 40s, especially amongst men, related to alcohol, suicide, all sorts of these sorts of factors. And in part, this is what's causing that. We're getting a lot of premature deaths amongst these groups that's causing that to happen. Okay, we don't quite see that in women, but we see that in men. Okay. So this is some other work that now we're developing further with Claire Bamborough down in Durham. And basically, this is a welfare state-based analysis, and this is for 2006. And this expands it a bit more from the first diagram I showed you to include a lot more countries. In fact, this is nearly every country in the human mortality database. And there's life expectancy and there's inequality running here. The most important thing I want to emphasise, firstly, is that there is some welfare state relationship. The Scandinavian countries do pretty well, apart from Denmark, which is a prime example of where you have really poor tobacco control. They have really poor tobacco control in Denmark, and that's the reason they don't do well compared to their Scandinavian colleagues. The USA is an outlier. There is a very strong relationship between life expectancy and inequality. Okay, and some people see this as a problem. In fact, I see this is the fundamental relationship, and it's certainly not a problem. In fact, demographers have shown that, and what they describe is an efficient life table. And they've shown that efficient life tables, i.e. that you maximise your life expectancy, the way to do that is to have equality. So you get maximum life expectancy if you lower the variance, essentially. So the USA achieves it's off the horizontal line, it achieves quite a high life expectancy. And the reason it does that is because for people who can get all their medical care, etc., they live a long time, it's of a really high standard. The rest don't, and that's not such a good thing. So they have high inequality, but they sort of buck the trend a bit, if you like. Scotland sits there and in not a very happy position because it's starting to get into the rounds, as we saw with some of the other comparisons, into some of the Eastern European countries, and not quite near what the ex-Soviet. Russia is a very sad story in that whole thing. And I apologise for the size of it, and there. Okay. And we can plot these all over time, and using some of the sort of presentational things I won't show you today, but you can see how countries go over time. And Scotland basically had a nice trajectory as it was lowering, and then it hit the 2000 and stopped increasing its life expectancy at the rate because it was getting higher inequality, essentially. Okay. Final graph, and an annoying message was coming up. Okay. Essentially, you can decompose this in saying which age groups are contributing. I've done this in a comparative sense. I've taken Sweden as one of the best performing countries, and I've compared Scotland here. So Scotland has lower life expectancy, and this is difference in the years, and these are the age groups running along the bottom. And this is inequality, lost life expectancy. And because Scotland has higher, you can see. And essentially, these techniques refit life tables loads of times, but with modern computing, you can do it really quickly. And essentially, it shows that we could solve some of these problems by being a bit better with child infant mortality. A lot of our problems, compared to Sweden, in terms of it, come in sort of the middle age. We use a lot of life expectancy here, and that causes quite a lot of inequality. You get into the older age groups, and this is a slightly complex idea, but there is a turning point. If you start to have basically higher mortality rates, at some point, that's actually going to give you a slight advantage in inequality. And that's basically because you're not making the top end of the distribution as skews. And you can work out which age this is for any country. So basically, if you saved a life above that age, you're going to increase life expectancy, but also increase inequality in your country. And it's very near to actually life expectancy itself. So essentially in Scotland for men, I mean, if you're saving a life above 75, if you didn't do the comparative before that, it would increase life expectancy, but also increase inequality. And there's complicated bits which I won't explain going on up here, but essentially these are the functions of the different distribution. But the advantage of this sort of comparative work, it allows us to see where we could be decreasing inequality and also increasing life expectancy. And you don't actually even need a comparative thing. You can work out for a country on its own how efficient its life table is across all the age groups. That's something slightly more complicated to explain, so I've chosen not to do it in the talk. So for me, this approach is very powerful in sort of helping us to unpack, firstly, the link between inequality and overall population health, and secondly, what we can do about it and what age groups we should sort of be thinking about where the problems are and how we can achieve sort of increases in both, increasing life expectancy while decreasing inequality. Okay, so there's large health inequalities in Scotland compared to many other countries. And something I didn't mention before from the SLS work was that the education variable, because it changed over time, was slightly difficult to compare. But we looked at it with some other measures like housing tenure, car access, Carstairs score of deprivation. And what we found was the 91 relative index of inequality was always slightly lower than the 2001 relative index of inequality, i.e. there was some widening of the gap over time. And that's been found in many other studies in many other countries. I would really emphasise that there's need to include Scotland in future comparative projects and really hope that that will happen. And my final thing is that given sometimes that we lack socioeconomic data, that there alternative measures exist. And one point that's made, and myself and Chris Dibben have recently had an article in a journal arguing about the sort of need for some of these alternative measures to be used. And some people come back and say, well, do they capture socioeconomic differences? You don't have a measure of socioeconomic status then. Well, if you take a sort of very wide sort of Michael Marmot sort of the social determinants of health approach, I would argue, it's not uncommon for us to say that variations in the level of population health, i.e. life expectancy across countries, have to do with things that are socially determined. And not just socioeconomic status differences, but lots of things that essentially have their roots in socioeconomic, socially determined differences between the countries. So I would argue that you could just apply the same logic, and the same logic holds when you look at variation. Of course, there will be variations not related to those sorts of things within countries, but mostly that variation should be sort of similar in different sorts of countries. And if it's not, it probably has some sort of socioeconomic determinant to it, related to the nature of the country and the type of society it is. Okay. So that's all I'd like to thank. I'd like to thank the co-author of the report, who is Paul Ball, who has done so much to get the Scottish Longitudinal Study going and also to get this project up and going. I'd also like to thank Chris Dibbin and Claire Bamborough for some of the elements of work on the measure of inequality. Special thanks to John and the Scottish Collaboration for Public Health for inspiration and also funding, which is always very important. And thank you to the Longitudinal Studies Centre for Scotland for having the SLS allowing us to use it for this. Okay.
So we have a little bit of time for questions or comments from the floor. A lot to digest there. Yes, Sarah.
Thanks to you both very much for very interesting presentations. I've recently been looking at all-cause mortality just in quintiles and socioeconomic status. I was very surprised to see a very different pattern in men from women, with a linear pattern for women, but this exponential increase in quintiles 4 and 5 for men. And perhaps I've missed this in previous data, but I don't think either of you showed your all-cause mortality, and just interested in comments on that.
I'm trying to remember from sort of the Carstairs and all-cause mortality results for men separately to women. I can't recall them off the top of my head, so I'm not going to claim that the great increase. That wouldn't surprise me, and we certainly looked in the report. I can't quite recall it off the top of my head.
One of the interesting things for the work we were doing was we were comparing mortality in people with diabetes and people without diabetes. And for the men with diabetes, there was an absolutely linear pattern, but with this exponential in the men without diabetes, so the relative risks were much lower in deprived men for diabetes and all-cause mortality, whereas for women there was a bit of a difference, but much less.
I have seen that pattern before in a social science and medicine paper we published on the Alameda County study in San Francisco Bay. And our interpretation is that for the generations who are dying in these cohorts that we're examining, who come from an era when women were not in the paid labor force to the same extent, the pattern of reverse causation is much more profound in men. That is, downward social mobility attends morbidities and causes a very high concentration in the lowest. If you measure socioeconomic status by any non-fixed measure, meaning income or current occupational status, as opposed to, say, basic education, which is fixed early in life. When you measure anything that's time varying, then you get this reverse mobility, right? Downward social mobility. And men are very, very strongly affected by it. So you get this big blip up in mortality. And in the Alameda County study, the blip went away completely when we deleted the deaths of those who died during follow-up. So I can send you that. So it's something you can look at. I think that's changing, obviously. It's a different world now. Other questions or comments? You're looking for a glass of wine now before the snow hits. Well, I want to... Yes, Alison.
Thanks. One of the things that we've identified is that the pattern for mortality amenable to healthcare intervention is the inequalities they appear to be narrowing in the most deprived and second most deprived population in this country, compared to Finland, which is the other country I know about these data. But total inequalities, in terms of all-cause mortality, the difference in Lothian particularly is between, for our least deprived population, it's Japan and San Marino. That's where we are. And our most deprived population is, for men, life expectancy is similar to Bhutan.
Wow.
And if you look at the income, there's not much difference in the income either.
No kidding. Wow, that's very striking. I think it would be good to do more work with amenable cause, as they call it, causes of death amenable to medical care, and parse that out. I think you've seen me present a Canadian study that shows that after the advent of Medicare, there was a complete stoppage of widening of the gap from amenable cause mortality. And once you pay for universal medical care, you stop the widening of the gap from causes of death amenable to medical care quite effectively in the modern era, whereas that isn't true for some of the other causes. So there is some good work to still be done there, I think. Yes?
Yeah, it's been extremely interesting. You were saying at one stage you felt alcohol was probably an important factor in contributing to the inequalities. And really, I suppose all that we're doing is looking for hunches and hypotheses that you can then pursue further. I think it would be very helpful to have more of a breakdown of what one means by social inequalities and more data on the different aspects of social inequality, housing and so forth. Because I think that would help firm up what it is about Scotland, because it's very striking, the difference between Scotland and other countries, and it's getting worse. I don't know what you feel about the alcohol issue. It's sometimes said that alcohol is driving this, and maybe along with suicide.
I think the evidence around the alcohol, I mean, in this sort of absolute, the age range that we were looking at was a slightly older, so basically people who were 30 to 74 at baseline. But essentially, those deaths have been driven by the older age deaths. The results will be in absolute terms. So in that sense, we didn't see alcohol as being so important. But Alistair Leyland's work, which is also looking at sort of inequalities in younger groups and breaking it down there, certainly shows the importance of alcohol and certainly alcohol-related disease. So in that sense, yes, it's very important. And I think some of the work looking at sort of Scots-born in England and Wales as well, if I remember rightly, shows high rates of alcohol there. But these are interesting issues as well. I mean, in some related work, we sort of had a brief go at looking at some of the Scottish effect elements to it. And for me, the most interesting thing is around Scots going south and sort of their maintaining high rates of death than we would expect, even though they do quite well down south in terms of work and socioeconomic status. So I think we have to think about this in a life course perspective, and I think that would really help. So.
Yeah. So we hope to see more work like this. We have an interest in furthering this, and if you'd like to collaborate in some way or you have a particular interest, you can reach us. Our little pamphlet at the back, it has our contact information and our website, and we also would like you, if you are interested in the early life policy and program interventions that have been demonstrated globally to both improve lifelong health and reduce inequalities. You're welcome to pick up a copy of Rosemary's new scan. This is Rosemary Geddes, who's just finished the first of our 4 scans of interventions in the global literature. So it's a structured review, but it's put into a Scottish policy and program context. So the rest of them will be up on the web site by the end of January. You can download them or let us know, and we'll send you a hard copy, because they cover the other 3 parts of the life course in terms of major public health problems in those age groups. And we're now working together with policy, program, and practice people in public health in Scotland to try and work towards having some of these intervention options trialed in a robust way, which is a difficult thing in a period of economic downturn, as you can well imagine. But we're never discouraged. So please stay with us for a glass of wine and a nibble and safe home, and I hope you don't face snow outside. Thank you. Thank you to our speakers. Not a very good
But it's
I think I enjoyed that. I did like it. It's really
that would be really nice to
all I would get is underwriting. Preferably, I would the death rate for 0, 1, 2, 3. Basically, in fact, essentially all building blocks of a life table which are more time.
You can get that
the only trouble is that slightly you'll run into because sometimes life tables get truncated where they just have death rates of 18+. The trouble is that increasingly it's more and more the majority of people don't die until that point. They become sort of you're losing information. But if you can get a life table that at least gets up to 90, I think that would work really well. Yeah. But any life table, and if you want, I can send you stuff that'll code and help out. That's absolutely
You might like to try this at GCPH.
I mean, this is something I have thought yet.
No, it's been great.
But isn't it the survivorship aspect? I mean, if you're made it to 70 or 80,
That's why you see those curves approximating that you showed at that very day.
No, I mean the numbers aren't. As long as you, I always think as long as you get into 90+, it doesn't matter. That's